On this video, we're going to work on taking the derivatives with given values from a chart, and we'll work on taking the derivatives more than once. But first, we'll start with taking the derivatives when the values of the numbers that you want are given by a chart. So let's take a look. On number 11, it tells you to find f prime of 3. And remember, we read math left to right, like we do anything else. So we are looking for the derivative of f first, and then we want to plug in 3 after that. So let's go ahead and do that here. On part A, we are going to find the derivative of f. Okay. 4 is a constant multiplier, so 4 just stays out there and chills. And the derivative of g would be, well, g prime of f minus the derivative, so 1 over 2 once again is a constant multiplier, so it stays up front. And the derivative of h of x is h prime of x. And the derivative of 1 will be just 0, so we are not even going to indicate that. And once we get there, since we found the derivative of f of x, we're going to find the derivative. We're going to find the derivative after. So we're going to plug in 3's into all of those. Alright, plugging in 3's into all of those. And then we're just going to have to read the chart. So, g prime of 3, it's right up there, is negative 2. Minus 1 over 2 times h prime of 3, which is pi. Now, if I simplify this, this really becomes negative 8 minus pi over 2. And I'm just going to leave it like that. Good. I hope this works good. Likewise, on part B, we're going to go ahead and do what we would usually do. Just because it has charts involved in it, it does not mean that it's any different than any other derivatives. Okay, so please keep that in your mind. So on part B, we're going to take the derivative. And as you can see on part B, there isn't really anything there. Okay, so I'm going to take the derivative as I would usual. So it's 4x cubed minus 8x. And then you realize, okay, I'm just going to go plug in 3 because that's what we're supposed to do. Okay. That's a lot of math, so I'm going to factor out 3. Okay, that's better. $36 minus 8. 3 times 26. Oh, 8. And then multiply 3. There we go. And then we're done. So on this one, we didn't really have to use a chart. We only use a chart when they prompt us to. If you don't like my algebra on this one, you can just work it through as you go. It wouldn't bother me at all, but you know how weird I'll work on something, but that's okay. Alright, that's it for working with the charts. Let's go on to take the derivatives twice. So let's take a look at number 12 on part A. Okay, if I were to take the derivative twice of part A, I would first take the derivative for the first time. Okay, which gives us 8x squared minus 10x minus 7. And for me to take the derivative twice, I'm just going to take it one more time. So this gives us 15x minus 10. Now, as of right now, you don't know why we need to take the derivative twice. You'll see it in applications later. However, as of right now, we're only working on mechanics, and you know I'll go ahead and tie it all together with conceptual side of things here and soon. As soon as we get good with some mechanical things, we'll pull it all together, okay? Now let's try with part C. Part C, before I take the derivative of that thing just right away, I'm probably going to make that derivatizable, if that's a thing that I can say. So the same thing as 4x to the 1 over 2 minus 2, I'm going to bring the square root up and make it exponent, give them an exponent instead of a root. Now let's take the derivative. The first time, it will be 2 x to the negative 1 over 2. See that? Multiply, take away. Once again, multiply, so 2 times 1 over 2 is just 1. And take away 1, negative 3 over 2. That's my first derivative. And I know your first instinct is to make this pretty and clean this up now, but however, there's no need to continue to take the derivative one more time. After you take your final derivative, then make it pretty as you go. I mean, you'll see the different cases, but as of right now, I think that's the best way to go about this problem. So the second derivative of this is same thing, multiply and take away 1. So if I multiply that, that's negative 1, take away 1, negative 3 over 2, multiply, negative 3 over 2, take away 1, negative 5 over 2. If I were to make this fancy, I'm just going to bring that down. Okay, bring that down. And that's it.